So in this activity, we are going to learn how to find a statistic to express how strongly two quantitative variables are correlated. And when I say correlated, I am referring to a linear relationship. There are many relationships that are not linear. The statistic that we'll calculate today only expresses the strength and direction of a linear relationship between two quantitative variables. The statistic that we're going to use uses the mean and standard deviation of the two variables. And the reason for doing that is so that you can come up with a standardized statistic that has a set range and is independent of the units of the variables being used. So the statistic that we'll calculate today and that we'll use many times in the future doesn't really care that in this case we're using weight here and that it's in pounds. It's going to be unitless, which is a nice feature of it. So the first task that we're asked is to find the z-scores for the Corvette and also the Saturn, SC here. And I think you know how to do this by now. A z-score is the value minus the mean. They tell you the mean. It's 2,997. You could have found that with one bar stats, but they told you it. So that's the vet's deviation from the mean for the weight. It's 298 pounds above average, but that's not good enough. I want to know how extraordinary that is. So I divide by the standard deviation of 357.6 pounds. Gives me a better understanding. The vet is not unusually heavy. It's only 0.83 standard deviations above the mean in terms of its weight. But it is heavier than average. So that's our blank here, 0.833. And then for the Saturn, we want to find the z-score for its fuel economy. It has the highest fuel economy, but we want to get a sense of how high in a relative sense is that number. So we find the z-score, 27 miles per gallon, minus the mean, which is given to us above, of 20.867. So the Saturn gets 6.133 miles per gallon more than average. How good is that? Let's divide by the standard deviation of 3.044 miles per gallon. Wow. That's pretty extraordinary to be 2 standard deviations away from the mean. So that gives me a better sense of relative position. 2.015. Okay? We're also asked to calculate the product of the z-scores. Now, in my view, this is an ingenious method of calculating correlation. It's hard for me to even imagine myself coming up with this method of just multiplying the z-scores together to come up with how strongly two variables are related. And we thank Carl Pearson. Thanks, Carl, for coming up with this method. So the product of the z-scores for the vet is 0.833333 whatever times negative 1.27. Negative 1.058 is the product of the z-scores for the Corvette. And then for the Saturn, it will be negative 1.613 times 2.015. So negative 3.25 about. Okay? Any questions on part A? Finding z-scores or finding the z-score products? All right. Next, we will add the results of the product column. I like to be lazy. So I will use this machine to do this quicker. In L1, I will put the z-scores for, in L3 I will put the z-scores for L1. So tell me what to type. I want to do this automatically. Let's be lazy together, okay? Louder, please. L1 minus the mean, but since I have multiple terms in my numerator, I will enclose them with parentheses. Okay, so L1 minus the mean, we are told it's 2997. Close paren. And then? Divide by standard deviation. Very good. You've learned some things. Entree. Those are your z-scores for the weights. Notice that they are equivalent to what the worksheet says. And now we'll do the z-scores for the fuel economies. Sounds like you get it now. Open paren. L2 minus 20.867, close paren. Divide by 3.044. Bam. And then, finally, I want my z-score products. Tell me what to type in L5. Yes, sir?
Oh, and then, but like I was gonna do like stat and calc and run bars to like get the product and
We need the products first.
never mind.
Okay, thank you for helping though. Yep.
L3 times L4.
L3 times L4. Those are the z-score products. Now, Krishna, what should I do?
To get the
We want the sum of the products. Think about what you told me before.
just go to
Stat,
calc
calc,
1
1.
L4
L5 is where I put my products. Yep. No freak list. Calculate. And which one is it, Krishna?
sorry. I'm getting
Well, just tell me on my screen.
okay. Would be like negative 11.
Yep. Okay. Capital Greek S stands for sum. So the sum of the x's is negative 11.4. And then we are asked to divide the result by 14, which is one less than the sample size. If I have time, I'll explain to you why it's one less than the sample size and not the sample size. But effectively what we're doing here is we are normalizing this using how many data points we have. Because hopefully you can understand how this sum here would change. It would be dependent on how many points you have. So we're getting an average by dividing by basically how many points we have. So negative 11.42 divided by 14, negative 0.82 about. This, my friends, is one of the most widely used statistics in the world. This is symbolized by lowercase r. This tells you the strength and direction of the linear relationship between two quantitative variables. So now we have a statistic. Notice that it's negative. That tells you the direction. So the relationship between weight and miles per gallon is negative, meaning as weight increases, miles per gallon decreases. Also, the 0.82 part. The lowest value that this can be is 1. The highest value can be, I'll try again. The lowest value of this is negative 1. The highest value of this is positive 1. This is pretty close to negative 1, so I will infer that it is a pretty strong relationship. Okay, so negative and fairly strong. So if I look at a scatter plot, I expect a negative slope and not too much scatter around a line of best fit, but some noticeable scatter that's there. Okay? Any questions on part B? Yes?
Can you repeat how you tell if it's like strong or weak?
Yes. R. Full name. The Pearson product. Okay, fortunately, we just call it R because it has a really long name. This is after Carl Pearson. This is because you're taking the products of the z-scores. A moment is Carl Pearson's lingo for a value minus the mean, which is what you do when you find z-scores. Okay? Correlation, that word is used to describe the relationship between two quantitative variables in a linear sense. And coefficient, because it can be a coefficient of something, it can be a multiplier. But anyway, to answer your question, R ranges from -1 to +1. That's as per Carl Pearson's design, and that's really cool. It has a standard range. -1 means perfect negative linear relationship. In other words, if you were to look at the scatter plot, the dots would form a perfect line. They would all be collinear, and the slope would be negative. +1 means a perfect positive linear relationship. So just sloping up. 0 means no linear relationship. It could have a very strong nonlinear relationship. Please be careful when you're using R.